These are the two terminals. Alternatively, you can call this metallic thermometer as a metallic or it is a temperature transducer. Metallic temperature transducer. Metallic thermometer or metallic temperature transducer or sensor. Neither way you can call. So usually here when you measure a temperature versus resistance, it will be linear. For a metallic thermometer, the plot between temperature and resistance will show a linear nature. Linear nature because it has a positive TCR value. So there is an equation which relates temperature as well as resistance. So for a metallic thermometer, resistance at temperature T equal to R naught into 1 plus AT plus BT squared plus CT cube into T minus 100. This is the equation for a metallic thermometer. Here RT is the resistance at temperature T, and R suffix naught is resistance at 0 degrees Celsius. Then A, B, C are all constants. One very good example for metallic. There are many types of metallic thermometers. One is platinum. Its measurable temperature range is from minus 200 degrees Celsius to around 850 degrees Celsius. And for copper it is minus 100 degrees Celsius to 260 degrees Celsius. And in the case of nickel, it is again minus 100 degrees Celsius to 260 degrees Celsius. As you know, cost of copper is very high when compared with copper and nickel. Also, you can see the benefits. It's platinum. When platinum is used as a thermometer, you can measure in the temperature range from minus 200 degrees Celsius to 850, whereas others are, though they are cheap, its temperature range is limited. Copper and nickel. One example is of a metallic. Most familiar example is PT100, platinum 100 thermometer. platinum 100 thermometer is the very well known example for metallic thermometer. Here 100 means resistance, that is R naught. At 0 degrees Celsius, its resistance is 100 ohms. So it is called as PT100 thermometer. Resistance of platinum is 100 ohms at 0 degrees Celsius. So it is called as PT100 thermometer. So the next one is semiconductor thermometer. Whiteboard is taken. Whiteboard. Semiconductor thermometer, or alternatively it is called as semiconductor temperature transducer or sensor or thermistor. Or simply thermistor. So another name is thermistor. Okay. So these are all. So it's usually a small pellet is used as a. Its size is semiconducting thermometer, and with 2 leads. It's a small pellet or small beads. Its thickness will be around maximum about point. Its diameter is about 0.5 centimeter to nearly 1 centimeter, and its thickness is about 0.01 inch. So its diameter is about 0.5 to 1 centimeter, thickness 0.1 inch. So smaller one. Usually germanium is used. Germanium semiconductor, or some doping, some elements can be doped into germanium not to get improved sensitivity. Germanium based thermistors are very good example, and it's very good working temperature range is from -100 to 300 degrees Celsius. -100 to 100 degrees Celsius to 300 degrees Celsius. Of course, because of negative resistance PCR value, it will be non-linear temperature versus resistance. When with increase of temperature, resistance decreases. Resistance decreases. It will be non-linear. So non-linear. And there is an equation which connects resistance as well as temperature. So 1 by T equal to A plus log R suffix T B into log R suffix T plus C into log R cube suffix T is the equation which is responsible for this nonlinear nature. To represent nonlinear nature, logarithm is given in this equation. So, of course, A, B, C are constants, and T is the temperature, R suffix T is resistance. So, A, B and C are constants. So, it is all about different resistant thermometers. So, see you in the next video.